This is a video to explain and show how air freight CO2 emissions are 46 times more than sea freight, and why the UK fashion industry needs to lead the way by example to the rest of the world with a practical solution for the world to follow on eliminating the use of air freight to ship finished apparel products from the production hubs of the world. The four main production hubs being China, Vietnam, India and Bangladesh. Global air cargo accounts for approximately 25% of the total use of global aviation fuel, and a big part of that is apparel and clothing products that are air freighted to the Western markets from these four production hubs. The aviation sector is a top 10 global CO2 emitter and accounts for 4.9% of the warming impact on the Earth. The ultimate goal of Kyoto Kids is to bring about a complete worldwide ban on the air freight of apparel products, in the same way that we have a worldwide ban on CFCs, also known as chlorofluorocarbons, as we know that these damage the ozone layer. We cannot continue to make use of air freight simply to get our clothes 3 weeks quicker than if we ship by sea on a container ship. The true extent of the problem is millions of tons of clothing products being air freighted around the world. Imagine we could stop that and ship by sea instead. That would eliminate millions of tons of harmful CO2 from entering the atmosphere and would be a huge step forward for the fight against climate change. Imagine we could get that victory for our children's future. It is possible, and I'm going to show you how it can be done in this video, so please keep watching until the end. Please like and share this video in order to spread this message of what we can achieve and what is possible. I have been in the clothing industry for more than 25 years, and I've been working on this project for more than 10 years. I know what I am talking about, and I know that this is possible. As we move through history, we need to ask ourselves, will we still be making use of air freight to ship our clothing products in 20 years' time as climate change gets worse and worse? Now is the time to stop this. What sort of a legacy are we leaving for our children? I ask myself, how can I keep quiet about this when a solution is possible, which I will talk you through in this presentation. Right now, more than ever, the world needs to find solutions to the climate change problem, which is only going to get worse if we continue the way we are. We need to do all we can to slow down the rate of climate change in order to give our children hope for tomorrow, that solutions are available to tackle the problem. Kyoto Kids offers the fashion industry a workable and practical solution, which I will talk you through in this video. We also need to remember that the UK has a legal obligation to go carbon neutral by 2050. The UK needs to live up to its responsibilities on implementing solutions now that a climate emergency has been declared. But in order to look forward, we first need to look back through history to where it all started, how it all began, and why it is so important that we tackle the air freight issue of fashion products. Textiles were the leading industry of the Industrial Revolution, primarily through the mechanization of the spinning and weaving of cotton fibers into yarns and fabrics through coal-fired, steam-powered cotton mills in the north of England. The Industrial Revolution, which started in England, is why today there rests a responsibility on the UK fashion industry to lead the way and to be at the forefront of innovation to the rest of the world with solutions to the climate change problem, as the UK textile industry was at the forefront of global innovation during the Industrial Revolution. This year, 2020, is the time to change, not in 20 years from now when the ice caps have melted and polar bears are extinct. It's clear that climate breakdown isn't a distant idea. It's here, right now, in our lifetime, and we have to treat it like the emergency it is for our children's future. Clothing is an essential human need. It is the base physiological need on Maslow's hierarchy of needs. We need clothing both to cover our nakedness and to protect us from the elements. Fashion, which is the creative element of the base need of clothing in its raw form, can also be used to carry a message, and that is exactly what we are doing with Kyoto Kids as a brand. It's impossible to solve the climate crisis and keep temperature rises to below 1.5 degrees as per the Paris Agreement, while millions of tons of apparel products are needlessly transported around the world each year, simply to get them on the shelf 4 weeks quicker than if shipped by sea. Now, there are two types of air freight that are used in the fashion industry today, which I will be covering in this video. The first type is where the price of air freight is costed into or built into the retail selling price of the garment, in order to bypass the 4-week shipping lead time and get the goods into stores faster and cash in on the surge of sales while the product is trending. The second type of air freight that's used in the fashion industry today is where a UK retailer or an overseas supplier, or both together, have not correctly managed and followed the critical path, or also known as the production timeline calendar, and this has resulted in the garment order running late and missing its sea-sailing container vessel, with the end result being that the order is air freighted right at the end in order to ensure that it's delivered on time. In other words, the pre-planned 4-week shipping lead time is used to finish sewing the order. Now finally, at the end of the video, I will explain how the harmonized system, also known as the HS tariff codes, can be effectively used as a way or as a tool to control or stop air freight of apparel products by air shipment, as these codes are internationally recognized in over 200 countries. But first of all, let me start by explaining the maths behind how we work out that air freight CO2 emissions are 46 times more than sea freight. This slide that you're looking at now is from the UK government and is referred to as a freight transport conversion table. This table is from 2008. However, not much has changed on the conversion factors, but this is a very good example to understand and explain to others, as the tables today have become more complex. I believe in keeping climate change as simple as possible, as it's a complex subject. You will see on the top left I have circled shipping, and further down I have circled air. You will also notice an arrow under each mode, which are the ones we are going to discuss. On the shipping mode, I have placed the arrow next to large container vessel, as that is what is used to ship containers from the clothing production hubs. First of all, we need to work out the ton kilometer, also known as TKM, which is the distance that the cargo travels multiplied by the cargo weight. This figure is then multiplied by the kilograms of CO2 per ton kilometer. As you can see, our large container vessel produces 0.013 kilograms or 13 grams of CO2 per 1 ton of cargo for each kilometer traveled by sea. Now, let's discuss the air mode of transport, which is circled further down on the slide. You will notice that the arrow is pointing towards long-haul international, which is what we have used to fly clothing from the 4 main production hubs, namely China, India, Bangladesh and Vietnam, to the Western markets. Exactly the same principle as for sea. We first work out the ton kilometer, also known as TKM, which again is the distance the cargo travels multiplied by the cargo weight. This figure is then multiplied by the kilograms of CO2 per ton kilometer, which in this instance is 0.606. As you can see from the chart, our long-haul air flight produces 0.606 or 606 grams of CO2 per 1 ton of cargo for each kilometer traveled by air. One other thing about air freight is that we also need to multiply our answer by 109%, which is known as a kilometer uplift factor. The IPCC requires this in order to take into account that planes do not always fly in a straight line. They have to circle and stack when landing, as well as fuel used on takeoffs into headwinds. To conclude and summarize, if you divide the amount of 0.013 into 0.606, it goes in 46.6 times, which is where I get my information from that air freight CO2 emissions are 46 times more than sea freight. In this next slide, we can see a real-life example if we had to fly 1 ton of cargo 5,000 kilometers versus 1 ton of cargo sailing 5,000 kilometers by sea on a container ship. It's exactly the same principle as the previous slide. We first work out the ton kilometer, or the TKM, which again is the distance the cargo travels, multiply by the weight of the cargo, and then multiply by the conversion factor per kilometer, which is 0.606 for air and 0.013 for sea. In this instance, we're working with 1 ton of cargo which is traveling 5,000 kilometers, so it remains 5,000 kilometers. If, for example, we are working out 2 tons, we would then multiply 2 tons by 5,000 kilometers to get a figure of 10,000, which we would then multiply by the conversion factor. In this example, you can clearly see that by air, for 5,000 kilometers, the amount of CO2 produced is more than 3,000 kilograms of CO2, whereas by sea, it's only 65 kilograms of CO2 for the entire journey of 5,000 kilometers. Percentage-wise, that's a 98% difference. Air freight thus produces 98% more CO2 than ocean-going container vessels. You need to remember that this is simply to get the clothes into the UK 3 weeks quicker. It does not make sense in this day and age to air freight clothes into the UK or anywhere else in the world, churning out 46 times the amount of CO2 than by sea, and just so that we can get them into stores 3 weeks quicker. Now remember, we have worked off an example of 5,000 kilometers. The actual distance from China to the UK by air is around 9,625 kilometers. From India and Bangladesh to the UK is around 8,000 kilometers by air. and from Vietnam it's more than 10,000 kilometers by air, so the amount of CO2 for a ton of cargo is more than 6,000 kilograms, versus 130 kilograms of CO2 if shipped by sea. We don't know the exact amounts of apparel products that are air freighted around the world each year, as the IATA, that's the International Air Transport Association, don't publish this. However, it is definitely in the millions of tons worldwide, and definitely hundreds of thousands of tons coming into the UK. During 2018, approximately 63 million metric tons of air cargo was flown around the world, and I would safely say at least 10% of that is apparel products, possibly more. So do the maths. At these numbers, in the hundreds of thousands and in the millions of tons, work out those CO2 emissions by sea and by air, and you will see what I mean by how we could stop millions of tons of CO2 from entering the atmosphere if we stop making use of air freight. Now, as I mentioned at the start of this video, there are two types of air freight used in the fashion industry today. The first type is where the price of air freight is built into the cost of the garment in order to speed up delivery and get the order out of the production hubs and to the final destination in a few days. The second type is where the overseas supplier or the UK retailer have not effectively managed the critical path, which is the slide you are looking at now, thus causing them to miss the container vessel sailing date and having to make use of air freight to move the cargo into the UK in order to meet the delivery. It's probably better if I explain this slide first as the critical path, then you can understand timelines and shipping lead times and the sequence in which things need to happen in modern clothing production methods. What is key in all of this, as you will see, is the yellow cell saying the 20th of June. This is the latest date that the finished goods can leave the factory in order to move down to the port and meet the cargo ship sailing to the UK, which is a 3-week journey from India, which we are using for this example. China is a 4-week journey, it's slightly longer. You will see the black circle around the last 4 cells. This is the allowed shipping time and is crucial to be understood and respected, as this is the golden key to the solution in avoiding and eliminating air freight. Now, let me walk you through from the start and the sequence of key timeline interventions that need to happen at agreed dates in order to make sure that we meet the 20th of June in the yellow cell, which is the key date that our goods must leave the factory to make their way to the port for sailing on the container vessel. For the purposes of this example, we're going to work off a 4-month or 120-day timeline. That is the date from which the purchase order is raised to the date that the goods are delivered to the UK retailer. On the far left, you can see the purchase order, which was raised on the 18th of April. The country of origin is India. We have an image of the style, a short description, and the units. The first date in green saying the 2nd of May is for the lab dip to be approved. Now this is a match or replica of what the bulk fabric is going to be like. Next to that, we have another date of the 2nd of May, which is for the fit sample. The fit sample is a sample which is made up front. It can even be from a substitute fabric similar to the bulk. This is purely to get the fit or the measurements and size correct before we move on to the pre-production sample, which is an exact replica of the bulk. We are planning to get our bulk fabric in-house on the 6th of May, and once we have that, we can make and submit our pre-production sample on the 16th of May. It's essential that all of those events happen on the dates that they are meant to, so that we have enough time to sew and pack the order and make sure we leave the factory on the 20th of June. Now, what generally tends to go wrong is that the UK buyers can take their time to approve a fit and pre-production sample, or they can request changes to the fit and pre-production sample. Sometimes, this is a case of the factory having not correctly followed the measurements they are meant to. Other times, the UK buyers have changed their minds and want to try something different. This is a very high-level overview of it, however the principle I'm trying to illustrate, and what I see all too often, is that the fit and pre-production samples are delayed due to resubmissions, and the factory ends up having to sew the order during the circled area, which is the shipping time. In other words, the order misses its agreed date of 20th of June, when it's supposed to leave the factory, and the supplier makes use of the shipping lead time allocation to sew the goods. He then ends up air freighting the order right before the actual UK delivery date, which is the far right block. The goods may be flown in as late as the 1st of August. I found that this is often abused by UK retailers, and suppliers are forced to finance the cost of air freight in order to secure future orders and maintain good relations with their customers. UK retailers know this, hence why it is abused. This is why there rests a responsibility on UK retailers to ensure that fit and pre-production samples are approved on time, so as to ensure a harmonious flow of the timeline. If there was a worldwide ban on the air freight of apparel products, it would force suppliers, factories, and the UK retailers to manage this process more effectively in order to make sure that things happen on time. Under the current conditions, it's too easy to just stick the order on a plane if you are late. There is no accountability. On the flip side, if there was a ban on the air freight of apparel products, it would force the weaker overseas suppliers to either up their game and deliver on time, or go out of business. In turn, this will force UK retailers to work with reliable suppliers who can meet deliveries and execute good quality samples and orders on time. It will level the playing fields, and air freight will no longer be the easy way out. Now, this next type of air freight, the slide you are looking at now, is much more malicious than the previous slide. It is an example of the cost of air freight built into the pricing structure of the garment. It's costed for in order to deliberately bypass the 4-week shipping lead time and get the goods out of the production hubs and into stores immediately. In other words, it benefits the UK retailer to get the goods ASAP if something is in high demand or is trending and selling faster than planned. The retailer wants to cash in on the surge in sales in order to increase their profits. This can happen across multiple products and brands throughout the year, as merchandise planners use sophisticated stock allocation software to see what is selling faster than planned. I have personally witnessed amounts of up to 20 tons coming into the UK on a single day for one brand. UK retailers do this for all their brands. This has to stop. We cannot continue to allow this in the face of climate change. We cannot continue to fly hundreds of thousands of tons of clothes into the UK simply to get them onto the shelf 3 weeks quicker than if we ship by sea. If there was a ban in place for air freight of apparel products, it would level the playing fields amongst the retailers. There will still be clothes in the shops. We need a new retail model where timelines are extended by 4 weeks and the industry ships by sea. Now, this next slide that you are looking at is the Harmonized Commodity Description and Coding System, also known as the Harmonized System or HS codes. It is an internationally standardized system of names and numbers used to classify traded products between countries. It came into effect in 1988 and has since been developed and maintained by the World Customs Organization with over 200 member countries. Chapter 6101 to 6117 belong to the knitted garments. Chapter 6201 to 6217 belong to the woven garments, and Chapter 6301 to 6310 are for other made-up textile articles, sets, worn clothing, and worn textile articles and rags. These 3 chapters need to be restricted by law from entering UK airports and must instead be shipped by sea. Furthermore, these codes are all in the same 200 countries, hence why any country who has signed up to the Paris Agreement needs to pass a law that prohibits any of these from moving by air into or out of that respective country. It is a very simple solution to implement, it just requires the political will. Thank you for watching this video, and I hope that you found it informative. If you have any further questions, please send me an email to coyotekids@mail.com. Please subscribe to our channel and like and share this video in order to spread the message. Please also visit our website at coyotekids.ucraft.site, where we have a selection of quality kids t-shirts designed around climate change. All the proceeds are used towards funding our project and the ultimate goal of a worldwide ban on air freight. We also donate £3 from the sale of each t-shirt to Plant a Tree Today Foundation in order to enable a sapling to be planted here in the UK to act as a carbon offset for the life of the garment. We are only able to deliver t-shirts to UK addresses for now, however we are looking to find a way to deliver to Europe as well, in a way which reduces our environmental impact. Thanks again, and I hope to see you all soon. Bye.